Hi, I'm Michel Dufresne. I'm an independent consultant in the New York City area specializing in rule-based business application. This presentation is a part 3 of a 3-part series that talks about using the semantic web technologies for domain model of rule-based business application. In the first part, we talked about the web ontology language, which is a W3C standard, and in particular, we talked about the LDL, which is the description logic flavor of the language. This language is based on a formal logic-based semantic, and we looked at all 6 class descriptors that exist in the language that can be used to construct class constructors for building classes from expressions. And then we saw that we can infer or deduce the class-subclass relationships based on the class expressions. And then we looked at combining the description logic formalis with the logic programs formalis such that we could write rules on top of ontologies. Now let's look at using RDF for the domain model. RDF is a very flexible data structure that has the characteristics of a directed graph, and is supported in many programming language and has good XML serialization. For example, these 3 statements says that Mr. Dupont is a art collector and has an artifact called both party, which in turn is an impressionist painting. Now, we can access the RDF API directly to assert and navigate through the graph. However, this gets really complicated when there's a large graph with many classes and properties. It's preferable to have proxy classes specific to the domain model that access the graph. These proxy classes can actually be generated from the ontology in the programming language of choice. That would be either Java or Python or any other programming language. Here an example of how we would create those 3 statements using generated proxy classes. Basically would create instance variable of specific type and use a factory to create those classes, and as the class are created, it would assert in the graph the appropriate statements. Now we can infer on the domain model to apply all the logical entailments from the class constructors and the class axioms from the ontology. Rules can be generated to apply those logical entailments. So, for example, recalling in our example, we add a class constructors specifying that impressionist art collector is defined as the conjunction of art collector and all of the individual that has at least one artifact of type impressionist painting. We could generate a rule. Actually, those rules can be generated directly from the ontology based on those class constructors. Here the rule is very simple. Basically it says everything that starts with a question mark is actually a variable, and it says that if you have a collector of type art collector which has an artifact that is of type impressionist painting, then the collector must be an impressionist art collector. So looking at those 3 triples that we had at the beginning, and when we apply the rules, we would infer that our collector, Mr. Dupont, is actually of type impressionist art collector because he has an artifact that is of type impressionist painting. Now, this can be accessed using proxy classes where it provides a uniform interface to both the infer and the asserted graph. For example, from an API perspective, the first three statements here are the same as we had before, where we create an art collector, and then we create an impressionist painting artifact, and then we set that artifact to be the artifact of the art collector. Then we invoke the rule engine by calling infer, and then the rule engine will infer that this art collector is in fact an impressionist art collector. So it will classify the individual from a more generic type of type art collector to a more specific type, the impressionist art collector. Then from an API perspective, we could ask if our collector is actually of type impressionist art collector, and if it is, we get an handle to that more specific type. So what we did here is actually quite different of what you normally do in object-oriented. It's a little bit of a paradigm shift here, where we created variables not of a specific type like we did for impressionist painting, but we created a more generic type of the type art collector, and the rule engine told us is a more specific one, and we were able to cast down to the more specific type. Also, we could use querying to access the RDF graph, which is quite useful when you have a large and complex graph, so you don't have to navigate all of the domain model objects or the RDF API directly. Here we have a select statement where we select the collectors that are of type art collector. We get their artifact and the year and the artist who created the artifact. When we invoke those queries, we get results set in a tabular fashion that is very similar to what we get with using relational database and issuing queries to those databases. So this brings the programming model in a paradigm very similar to the one that we're used today, where we build web applications that access relational database and then produce views based on result set. The same approach can be taken here, with the difference that some of the information, some of the columns would be information, asserted information coming from the database, and some other columns would be inferred by the rule engine, but provided in a uniform fashion, in a single tabular fashion. So Top Engine is a semantic web rule engine that is a fusion between description logic and logic programs. So it allows to use description logic for the definition of the vocabulary primitive and to write rules using those vocabulary primitive. Also, Top Engine implement the LDL reasoning services, so we could ensure that the ontology is consistent before we add rules to it. And also we can write rules using a closed world semantic, so it would have a behavior very similar to the database as we are familiar today. The inference engine is written in C++ that use a Rete-based algorithm for forward and backward chaining, and also support querying capability. So that completes the third segment of the presentation, and I hope this was providing useful information. Please come and see us at differentconsulting.com. Thank you.